Problem overview. In this problem, you are given an array of distinct positive integers called candidates and a target integer. Target. The goal is to find and return all unique combinations of numbers from the candidates array that sum up to the given target. Each number in the array can be used an unlimited number of times in a combination. The key is to find all possible combinations that, when their elements are added together, equal the target value.
Pull up and I'm drifting in the whip. I got a baddie and she's trying to put my dick between her lips. So I ain't kissing her. I'm smoking on this pressure, rolling bodies in this blunt. I got.
So our approach here is backtracking first. We make a recursive call, and then in backtracking remove recently added and make a new call. First we make a function named backtrack. It takes candidates, target, list, start and ans as parameter. Now initially start is equal to 0. We add integers at index start and candidates give an array. Initially add 2 to list and decrease target by 2, as now our resultant target is decreased by 2. Note here we do not increase start cause. We can take any integer any number of time. So make these calls until our base case either less than 0 or equal to 0. So when it is less than 0, we make backtrack call, or when it equal to 0 means we got our one correct combination list, so add it to ans, and make call again. Careful here. When target is equal to 0, then we make recursive call, not backtrack call, as if our next element is 0, then we can add it, so we make backtrack call only if target becomes less than 0. So finally we got our one answer. Now store it in ans and proceed further. Let's move to code part. You will get C++ and Python code in end with same logic implementation. Initially, we have a list and list of list-ons. Now let's start develop our backtrack function code. So our function takes given candidates array, target, list, start as 0 initially and ons. Now first write recursive and backtracking calls, and then we think about our base cases. So in recursive call add our integer, which is at start index and candidates array, and here is 2. Now also our resulting target is decreased by 2. But here we are not increasing start because we can take integers any number of times. Now in backtracking call remove recently added integer, and this time increase start by 1, but note here, we are not adding any integer this time, so our target remains same. Now move to our base cases. First, if our target becomes 0, then we got our one correct combination, so add it to ons and return. Another case 2, when we have to return simply, without doing anything. In that case, we have 2 situations: either target becomes less than 0, or start greater than or equal to length of candidates array. So this is our logic implementation. I hope you got clear understanding. Here is C++ code. And here is Python code. If you are C++ or Python or Java coder, it does not mean so much. You can switch or understand any language in just 15 to 20 codes. See you with next backtracking problem.